Okay, example number 3. A box of mass 20 kilograms. So let me highlight what are the available information. Gray lah. 20 kilogram, mass 20 kilogram. Lepas tu rough plane. So they have frictional force. Inclined to the horizontal at 25 degree. Pulled by a horizontal force of magnitude 250 Newton. Coefficient of kinetic friction is 0.3. So if the box had traveled 3.8 meter along the plane, determine the work done, blah blah blah. Okay, so now what we have to do is we have to imagine the situation. So how do we imagine that? We are gonna draw it. Okay, so there's an inclined plane. Okay, so this is your inclined plane. It is 25 degree to the horizontal. Okay, and then we have this box, something like that. And then now what we have to do is okay, so there's a horizontal force of magnitude 250 Newton. Okay, it is pulled by that horizontal force. So there's a horizontal force. Okay, so let's label that as F. Anything else? No. Okay, now we have to draw what? The free body diagram. Okay, so this is our object, and then let's draw the inclined plane, something like that. And then now let's draw the forces. Okay, so the forces I'll do it with orange. Okay, so of course we do have weight because dia sudah bagi kita the mass. So we have mass. We have the weight pulled by gravity, and then we have the normal force, and then we have the, what was that? The friction, the force, horizontal force, and then we have the friction force going against the motion. The only thing that we don't have is the tension. Sebab there is no rope. So why would we have tension? So this is the object. Okay, so this is the mg force, and normal force, frictional force, Fk. Okay, now let me draw the x and y axis. I need black color. Right, so this is your y-axis. Remember, it always sticks with the y-axis. So this one here will be our 25 degree, and then the angle 25 degree here is equal to this angle here. So you will have here to be equal to 25 degree as well. Okay. Alright, what else do we need? I think that's basically it. Let me just label, this is x, this is y. Okay, alright, now the okay, so now let's start by answering the first question. It is asking us to find the work done by the force. Okay, so work done by the force is just Fs cos theta. Okay, so now I forgot to label the displacement. So the displacement, where is it going? So where is this block going? It is going to this direction. Sebab dia kena pull to that direction. So if it is being pulled to that direction, meaning that the displacement is also going to that same direction lah. So acceleration, this is acceleration, this is the displacement lah. Okay, right. Now, what do we have? We have the force. We have to write, what's the value of F just now? It's 250. The value of the displacement is equal to 3.8. It's given in the question. Cos, berapa degree the angle between the displacement? It is equal to 25 degree. Okay? Macam mana boleh dapat 25 degree? Sebab sekarang ni kita punya displacement is this direction. So if we put this here, dekat di sini ni, we can see that the angle between F here with the displacement is 25 degree. Okay? Okay. Now plug the values into the calculator. You'll then get the work done by the force to be equal to 861 joules. Alright, we've done this. Now, work done by the box. Work done on the box by the gravitational force. Okay, let me just label this is by the external force. And then they cari by the gravitational force. So I'll just put G lah. Gravitational force kan. So gravitational force work is equal to mg displacement cos theta. Okay, so now we have to resolve this mg. We have to find this angle. So what is the angle between, let me just try to draw this. So what is the angle between this displacement, this is S, with this mg here? Okay, so how do we do that? Is this one now, kalau kita buat begini aja, it's not enough. We have to go into the direction. Terbalik. Sekejap. So this is S, this is mg. So remember, we go from the S. Wait, something's wrong. So S is equal to 180 plus 90 minus 25. So wait, 180, 90 minus 25 plus 180. So we have 245. 245 cos 245 times S 3.8 times 9.81 times dengan M, which is 20 kilogram. Okay, so correct. Okay, so sorry about that. So if we have the displacement here, we are gonna go from S going towards the force yang we are looking for. Okay, so in this case, we have 180 degree plus dengan this angle here. So what is this angle? It is 90 minus 25. Okay, so angle yang di situ is 180 plus 90 minus 25 is equal to, let me check, 245 degree. Okay, so now we have M 29.81 3.8 cos 245 degree lah. Okay, you'll then get the value negative 315 joules. Okay, so that is question number 2. Number 3 pula, work done on the box by the reaction force. Now it is by the normal force lah. Okay, so by the reaction force, now it is ns cos theta. Okay, so now let's look at the angle between the normal force with the displacement. If we see the normal force, this is the normal force, and then this is our direction of displacement. So the angle between the normal force and the displacement here is 90 degrees. So what does 90 degree angle means? It means that the work done is equal to 0 joules. Okay, next question 4. There's a lot of questions. Okay, so question 4, the work on the box by the frictional force. So frictional force Fks cos theta. Now the angle between the displacement, which is this displacement, with this frictional force is starting from S going to the arrow going to the force is 180 degree. Okay, so theta dia 180 degree. Fk dia ada kena bagi kat theta, so we have to find it. It is mu k n s cos 180 degree. Okay, lepas tu kita perlu cari pula value n. This is combination of chapter 4. Okay, so mu k n is equal to, guna color ni lah. So now we have to equal force at y is equal to 0. Thus we have to find n equal n minus mg sine 25 degree minus f sine 25 degree equal to 0. So dari sini kita dapat the value of n. So n is equal to f sine 25 degree. Terbalik. So plus mg cos. Sorry, this is cos. Okay, cos 25 degree. So cos 25 degree. Okay, so that is the value of n. Lepas tu kita darablah dengan value of s, which is the displacement, cos 180 degree. Then you'll get the work done by the frictional force to be equal to negative 323 joules. Okay, wow, it's kind of long. Okay, so make sure if you bump into this type of questions, you have to use chapter 4 punya knowledge. Okay, so that's why chapter 4 is very important lah. Okay, now number 5. Yes, last question for calculation, I think. Okay, so for number 5, we have to find the total work done on the box. Okay, so the total work done is just the addition of all the one that we've calculated just now lah. So tambah, you'll then get 223 joules. Okay, that's the end for work done punya. Now we have to find what to? We have to find if the speed of the box is 0 at the bottom of the plane, calculate its speed when it traveled 3.8 meter. Okay, so this one pula we have to use what? We have to use chapter 2 punya knowledge pula. Okay, so this one we have been given that the initial velocity to be equal to 0 lah. Okay, so equal to 0. It starts from rest. Lepas tu, we have to find the acceleration. Sebab sekarang ni dia tidak cakap dia constant velocity. There's a change lah. Okay, so what we have to do is we can use total work done to be equal to MAS. Okay, sebab dia moving kan, dia ada acceleration lah. So 223 joule, m is 20, acceleration is what we are looking for, 3.8. So acceleration is then equal to 2.93 meter per second square. Okay, lepas tu barulah kita boleh cari dia punya velocity after dia sudah travel for 3.8 meter. Okay, so what formula are we using? We are using v square u square plus 2as. Okay, so v is the one we are looking for, plus 2a, 2.93, s is 3.8. So you'll then get the value of the velocity to be equal to 4.72 meter per second. Okay, so chapter 5 is a combination of chapter 2, chapter 4. Lepas tu dia combine dengan the chapter itself lah, chapter 5. Okay, so make sure your basics in chapter 2, 4 are very good so that you can excel well in this chapter lah. Right, so that is example number 3.